This is a bubble case, a case created by me using the well-known blender. All the buttons are functional, the openings are present, and most importantly, it doesn't look like other cases. A huge number of people use Apple technology, and the most interesting thing is that all their phones look completely identical. This means everyone walks around with the same device, and there is no authenticity. And this is where accessories come into play, adding all the variety. I personally love industrial design, and I simply can't ignore this topic and not create something of my own. By the way, this video will be divided into two parts. The first part is DIY, where I will explain and show the entire process from the idea to the final result. And in the second part, we will break down the animation that you saw at the beginning of this video. We will analyze the geometric nodes, animation, lighting, and everything else. So, shall we get started? If the main purpose of the bubble case is protection, then my product must inspire trust and confidence that it will withstand a fall. And I also didn't want it to be too bulky for the iPhone and not resemble its analogs. I had been thinking about making such a bubble case for a long time, but I didn't have the resources to fulfill this desire. It all started when I tried to make a bubble case out of liquid silicone. I made a master mold from regular resin, but nothing worked due to the thin walls. But just recently I added photopolymer resin with rubber-like properties to my arsenal, and today I have my second attempt. It all starts with the initial sketches. On paper, we sketch the first drawings and envision how our product will look. I decided to create the entire volume with decorative bubbles that will be located on the back and side covers of my bubble case. They won't add too much bulk and will help protect the iPhone from falls and of course prevent it from breaking. We will model this in Blender. We download a model of the iPhone from stock sites and adjust the dimensions that I found on the internet. Here, we will use an add-on called Sketcher, which will allow us to create a drawing that replicates the silhouette of the phone. We turn the sketches into a three-dimensional model and embrace our phone. I will create the bubbles using spheres. We cut off half of it and use a couple of modifiers to make it easier to work with multiple bubbles at once. I copy them 5 times onto the back cover and get the first shape. To fill the space next to the camera and avoid creating visual noise, I simply rotated our speed bumps 90 degrees. Next, we look at where the buttons of the iPhone are projected and create the same bubbles on the surface of the bubble case, but they will not be full so that they can press our buttons. We work with the holes in the same way. We smooth all the edges to maintain the entire concept. Great! I've prepared the figure, now we move on to the printing stage. We upload the STL file into Box, which is a program for print preparation, and set the supports. Honestly, I didn't really want to ruin this back cover, so I placed supports along the frame to preserve the most beautiful part of this bubble case. I'm amazed by the printing time, and I plugged the flash drive into the printer. Printing took 9 hours due to properties of the photopolymer resin. After cleaning the model from excess photopolymer resin, I expose it. Now we find the iPhone 13 and try to fit it into the bubble case. Let's check. The buttons press down, the holes align, and visually it doesn't overload the phone. Also, just for you and to practice myself, I decided to create a 3D animation that will accompany this video. You saw this video at the beginning of my release, and today we will repeat it. Once again, I want to remind you that you can download this project completely for free via the link in the description on my Telegram channel. Since the word bubble is even in the name, we will be creating an animation related to some bubbles. Most likely, it will be with soap bubbles. The first thing we need to do is create the effect of a popping bubble. Here we have a bubble and we need to... It will burst the way it does in real life, that is not instantly, but gradually. And he creates small splashes as he pops. It may be imperceptible in my animation, but with the geometric notes we will create today, it can be visualized in that way. Today we will be able to visualize it this way. So for this we need to create a UV sphere using Shift A. Next you can apply the subdivision surface to it. Then we add the geometry node editor and create geometric nodes. The first thing we will create is the set position. This is necessary so that we can simulate the swaying of our bubble as it happens in reality. meaning that some air currents affect it or its own weight. Let's make a set position and place it between the input and output. Now in the offset section, we need to add a noise texture. Set the scale smaller, and between the textures and set position, we add vector math and change the operation from add to multiply. We will make the vector small. I set it to 0.15, and to make all of this move, we need to change the dimensions. From 3D to 4D, we have this slider W, which represents the time interval, but to avoid having to rotate it ourselves, and so it spins automatically when we press play, we use a node called scene time. We add it to W and we have great. Next, we need to create the actual destruction of this sphere. We will do this through a node called delete geometry. We create delete geometry and place it between set position and output, and it disappears. Next, we need to select the selection, meaning how it will disappear, I don't know. So, I decided to create it using the gradient texture. We add the gradient texture and the noise texture. It may not change anything for you yet, but this is the time. We also need to add regular math, not vector math, to our calculations, which will serve as the factor for the appearance and disappearance of our bubble. In order to properly and effectively control the timing of the appearance and disappearance of our bubble, if we rotate it left and right, it will disappear and reappear. Here. Great. Now we need bubbles that will burst at the moment. The main bubble breaks. But it is important for us that these bubbles appear and disappear precisely at the edge of the bubble that is bursting, just like in my animation. So we will place instant sun points and connect it from set position to instance on points. And in the end, join geometry will combine all of this. Now our task is to create instances, that is, these examples of bubbles. For this, we press icosphere to add it and make it smooth, using the shade smooth node. We will add a material. I made glass, but it will be good to add glass to the material. And we will connect it to the instances. We will already have little bubbles across the entire area of our object, but that is not what we need. We need them to be specifically at the edges. Therefore, that is our task. In instance.onPoints, we will take the scale point and connect it to color ramp. The color ramp will indeed be the connecting link between the mathematics that actually affects the disappearance of the bubble itself and will connect to the scale through the color ramp. This is exactly how I made it. So here you will notice that right here, where the edge of our shape is, the balls are large, but where there are no bubbles, they are small, or they are hardly visible at all. They are practically invisible. So if I rotate it, we will change its position. This is how they will dissolve according to our design. Great. Now we need to connect map range in order to properly and accurately have the sizes from the maximum size to the minimum size. This is purely for variety. You can do it like I did with these sizes. And this will be an intermediate place between color ramp and scale. Great. Now our task is to add a bit of variety. I decided to remix this with a texture that allows for variety. Here it is without it, and here it is with it. This is needed for variety. It can be done without it, but I thought it would be better with it. Let's connect map range so that we have sizes from maximum to minimum in order to effectively and accurately achieve the desired result. This is purely needed for variety. You can do it like I did with these sizes. And this will be an intermediate place between color ramp and scale. Great. Now our task is to add a bit of variety. I decided to mix this with a texture that allows for variety. Here it is without it, and here it is with it. This is needed for variety. You can do without it, but I would say that it's better with it. And I also mixed in map range, where I plugged in random value, which allows them to range from maximum to minimum. But since these bubbles, if you watch the video of how it all works in real life, are indeed small, I think they should be made small. Great. Now we have an animation that allows us to pop a bubble. To create the actual animation, we need to move this math node. That is, you need to understand where at which value the bubble is a fully complete sphere, and when it is at its minimum, when it disappears. I found that -1 means I have a full ball, while 0 means there is no ball. Well, it makes sense. Now I would like to diversify the distance and the vectors where the bubbles will pop as the last step. I inserted set position between set material and instance on points. These are the nodes that allow you to set the position for something. In our case, this applies to all instances, which are these bubbles. Next, I took vector math and plugged it into the offset, then set it to multiply. I randomly assigned a value. And now they all move in one direction, but if you look at the video in the render, it doesn't look like they are just offset. They actually appear to be floating randomly. And if you scroll through the entire animation, you can see that our ball, like a real bubble, moves. It is not just sitting in a sphere, and at the moment we want, it becomes bursting. And the last thing we need to discuss today is the appearance of this bubble-shaped text. That is, how I achieved this, how it comes together into a complete text and floats away. It all starts simply. First, we need to create text, so press Shift-A, yes, and select text. We write the text that interests us. In my case, I wrote bubble case. Within the text settings, we can immediately extrude it, choose the desired font, and then we convert it into a mesh. Next, we open our favorite geometric nodes. We open the geometry nodes and insert the first node called mesh to volume. This means we are converting the entire mesh into a volume. Next, we need to spread the points, the little dots, within this volume. And we add distribute points in volume. Next, we add instance on points. That is, some objects will be located at points, and these points are distributed throughout the volume, which will create a randomized effect. That's all. Next, we plug it into the output. Now we have nothing is visible. And now we need to create an icosphere. Again, we create it in the same way. We make it smooth. We can subdivide it a little to make it look nicer. We apply the same glass material and insert it into the instances. And we basically get what we need. Here you can play around with the density settings in mesh to volume and density in distribute points in volume. I ended up with 600 by 100. You may have different numbers, whatever you prefer. Great, now we need to make them a little more diverse. All bubbles are not the same, so we will take random value and plug it into scale, and they will be randomized. And the last thing we need to do is the appearance. That is, they somehow float up, form into text, and rise upwards. Here, everything is simple. We take the gradient texture. I chose the Ising type. I don't remember how it translates through vector mathematics. Add. I will insert it between the texture and set position, which in turn is placed between set material and also instance on points. Thus, we can pull one of the sliders. In my case, it's the middle one, slightly up and down. That is, they somehow pop up, form into text, and rise upwards. It's all quite simple here. We take a gradient texture. I took the Ising model. I don't remember how it translates through vector mathematics add. I will insert it between the texture and set position, which in turn is placed between set material and instance. And thus, we can pull one of the sliders. In my case, it's the middle one, and it will spread up and down in add operation mode. This is exactly what I made the animation for. So, my first animation is at -3, and as you can see, it is already at the bottom at its maximum, and then it goes to 0. 0 is the very value that was, in the ideal case, to make the text readable. And then it simply transitions from -0.3 to 0.3, exactly, precisely. It moves more slowly so that the text is more readable, meaning it has slowed down, and then continues to a positive value, again up to 3, or rather up to 2 or 3, maybe more, which means it is already going out of the frame. And it turns out that the text has completely disappeared. So, that's the animation. I will repeat. If you want a finished project, want to play around with it, you can add something, maybe print a similar case. Please, you can do all of this in my Telegram channel via the link in the description. Subscribe and get the project. Well, we won't say goodbye for long. See you in new projects.